Alrighty, so let's check out this question here. The first thing that we need to do is find out the current I, which is this current over here. And judging by this diagram, it looks like that's going to be the total current of the system, because the current comes out of the battery over here, and then it goes through this resistor over here. It gets to this node over here, and then it splits, right? Splits like this. So the current I is actually IT, I subscript T, meaning the total current of the system. So that's just good to know. Okay, let's follow the current here and see what happens. So first thing we might do is we have the current come out, the current go this way, current comes to this node over here, and then it splits off. This current will go down this way and then go back into the battery. This current will split off like this and go back into the battery. And then this current will go off this way and it will go down this way and then back into the battery. The current definitely does not go this way because there's nowhere for the current to go. The current can't just like go here and then come back. It has to follow one path. And there's no way to get from this point A back to the battery, so the current won't go down that way. So we can redraw this diagram. Let me just get rid of all these currents here. We can redraw this diagram to get rid of A, because it's not going to be relevant for our question. Oh, oops, sorry, give me a sec. So I'm going to turn on black. That will allow me to erase this. And there we go. Okay. So yeah, the current doesn't go down this way either. Okay. And just to be 100% clear, I'm probably going to erase this as well if I can see where the eraser is, which I can't. Okay, so we're just going to leave this little nub here for now. Okay, so continuing on, it's the total current of the battery. So whenever a question asks you to find the total current of a battery, like the total current coming out of the battery, usually what that means is that they want you to find the total resistance of the path of the circuit, and using that you can figure out what the total current is going to be. So let me show you. So first thing is, let's find RT, so total current or total resistance. Okay, so the current comes out and goes this way, and then you hit this node over here, and that node splits off like this, like this, like this, and like this. So the first thing I would do here is probably combine these two resistors. That's really the easiest way to do it. Because these ones are in series. As you can see, the current has to go through the 100 ohm resistor before it can go through the 200 ohm resistor. So it's got to do something like that. So they're in series, so it makes life a lot easier. That just means that we can get rid of this and change the value of this guy here to 300, because it's 300 plus 200. So that'll be 300. And this will just be a wire like this. Okay. Now, if we follow the currents, we'll see that, so the current comes out, goes out like this, comes to this green node over here, spreads out this way, spreads down this way, and this current here comes from the same node as this current that goes this way, and both the currents end off in the same spot. So that means that this 200 ohm resistor, this 200 ohm resistor is actually in parallel with this 300 ohm resistor. So we can replace these two branches with a single branch that has the equivalent resistance. So what we're going to do is get rid of this branch. And just so you know, when you're cutting a tree, you always start from the top. So since we're talking about branches. So, well, that has nothing to do with electrical engineering, by the way. So we get rid of these two branches and replace them with a single branch that goes down like this. And bam. So this one over here has the resistance equal to 200 parallel with 300. And 200 parallel with 300, that's equal to 200 times 300 divided by 200 plus 300. And so that's going to equal 60,000, I think, divided by 500. And that should equal 2 zeros are gone there, but then so it's going to be 1.2. I'm not using a calculator here, but it should be about 120. Okay. And even if I'm wrong, that's fine. You know, it's not a math course. It's more to teach you guys about circuits. So we're just going to go with 120. And you might be thinking, well, that's very small compared to 200 and 300. That's true. Whenever you have resistors in parallel, like let's say this one is 100, this one's like 400. Usually the parallel resistance, the resistance that you replace both of these with, is going to have less resistance than either one of them. So this one here might be like 75, for example. Okay. And let's not forget our units. So units here, 120 ohms. Okay. Now we have this 120 ohm resistor in parallel, in series with this 40 ohm resistor over here. As you can see, any current that leaves this green node has to go through both these resistors. So it has to go through the 120 ohm resistor first, then the 40 ohm resistor. So we're just going to replace both of them with a single resistor. So the way I like to think about it is I take this resistor and slide it, and then it rotates, and it rotates, and it slides up the wire into the position with the old, or this other resistor over here. And my computer is being extremely slow today, so I'm not able to actually get it to move where I want it to. Oh, there we go. So it combines with this resistor, right? So that becomes 40 plus 120, which is 160. And okay, so that old resistor is going to be replaced here with a wire. So we have okay, so let's look at the circuit again. We have current coming out like this. It goes over like that, hits this node, and then goes through here and goes through here. So that means that the 160 ohm resistor here is actually in parallel with this 160 ohm resistor. So if they're in parallel, that means that you can just slap them together. So the way I like to imagine it is like these are two vines, and the vines, they shake, I mean they go back and forth, right? They swing back and forth, and the vines come together. So this 160 ohm resistor vine just kind of collapses with this one over here. And what you get is a thicker vine that has two resistors on it. And the total resistance of that new vine, let's write it out. So, hold on, let me just erase stuff first. So this new one here, this new vine, here we go, is actually the combination of the 160 ohm resistor in parallel with the 160 ohm resistor. And whenever you have two resistors that have the same value and they're in parallel with each other, the resulting resistor will always have half the value as the original. So I don't even need to do any math here. Oops. Or maybe I should have. 80 ohms resistor. There we go. So 160 in parallel with 160 is equal to 80. Okay, and now finally we have the electricity comes out of the battery, goes through the 20 ohm resistor, goes through the 80 ohm resistor, and then goes back home. So this 20 ohm resistor is in parallel with this 80 ohm resistor, and so the resulting circuit looks something like this. There's a 15 volt supply, and over here we're going to have 100 ohms. Why? Because the 20 adds to the 80, so that's 100. And now we just have a resistor, a single resistor here, and a voltage supply. So all the current that comes out of the battery has to go through this resistor. And we have a formula, V is equal to IR, which describes the voltage drop across a resistor. So the voltage drop across a resistor is equal to the current that moves through that resistor. So in that case, it's going to be the I total. It's the total current coming out of the battery, right? Everything that the battery can release is being released and going down this resistor. So that's IT. And the resistance of the resistor it's going through is just 100 ohms. So let's write that out. So VD is equal to IT multiplied by 100 ohms. Now what's the voltage drop across this resistor over here? Well, the battery only has 15 volts to give, and this is the only resistor in the path. So that means that all 15 volts are going to drop across this resistor. So if we take our calculation over here, that's going to be 15 volts drops across the resistor, IT multiplied by 100 ohms. 15 divided by 100 is equal to IT, and that will give us 0.15 amps as IT, or you can write that as 150 milliamps. So that's the first question.